So let's look at dilute and concentrated copper sulfate solutions. So let's set up our reduction and oxidation table. Remember, reduction occurs at the cathode. So we're looking, it's negatively charged, so we're going to look for our positively charged ions. And at the anode, it's positively charged, so we're going to look for our negatively charged ions. Now, copper sulfate breaks up into copper 2+, SO4 2-. We've again got our H+ and our OH-. We've also got water. So let's look at what are our positively charged ions here. So we have our copper 2+, and we have our hydrogen, and we also need to consider water. With our oxidation, we have our sulfate ion, our OH- ion, and our water. And something to be aware of is that sulfate is quite a stable polyatomic ion. Sulfur is in its highest oxidation state, so really does not want to be oxidized. Also look on our table, and sulfate only occurs on the reduction side. It does not occur on the oxidation side. So we can rule out that sulfate ions are not going to be oxidized. So if I have inert electrodes where they're not participating in the electrolysis at all, then I don't have to consider any other sources. So if I have active electrodes, I need to also consider what the metal of the electrode is. So at the moment, I'm going to consider that it's maybe graphite electrode. So here I'm going to look at what are the values for my reduction. So I have my copper 2+, and make sure you're looking at the right copper 2+. So copper 2+ can go to the copper ion. I want the full oxidation, so full reduction. So I want the copper 2+ going to the copper solid. So that's the plus 0.34. Value. We want our hydrogen ion of the 0. And we want our water value. So again, that's our negative 0.83. Now remember, when it's reduction, we want the most positive value. So our most positive value was actually the copper ions. So my reduction is going to be my copper 2+ plus my 2 electrons, I've got my state symbol, to make my copper solid. Now on the oxidation side, I've got to consider, is it OH- or H2O, which is still going to give me exactly the same products. So I know that my 4OH- will make my oxygen. My water also makes oxygen. It doesn't really matter which of these you choose. I tend to, for ease, just choose the 4OH-. So we have our oxidation of my hydroxide. To make my gas and my water and 4 electrons. So in this case, it's not quite balanced yet. I need to multiply everything in my copper by 2. So I'll need 2 of those. This will change to 4, and I'll need 2 to do my full equation, balancing out and crossing out my electrons to be 2 copper plus my 4 hydroxide to make copper solid and oxygen gas and water. Which means that my products at the cathode, I'm producing copper, and at the anode, we're producing oxygen gas, because the water will just go back into the solution. Okay, so that's for dilute. In terms of concentrated, we can actually see, because this is quite negative, this is 0. It's still going to be with concentrated. If I'm increasing this, it's going to want to make even more of it, because remember, it's on the left. So if I'm increasing this, it's going to want to reduce even more. So it's still going to be the copper being produced, and we still don't have any competition occurring here. So the nature of the electrode also does make a difference in terms of electrolysis. So with our sodium chloride, we could only use inert electrodes because we can't use sodium metal because it's very reactive, and we can't use chlorine gas because it won't conduct electricity. So what we have to do for something where we do have a metal that can be used as electrode and conduct electricity is consider what would happen if I actually had active electrodes. If I had copper electrodes in this case, I have my original values of in terms of reduction and in terms of oxidation, where I'm considering my sulfate ion, which won't, in this case, oxidized. We're considering our OH minus, and we've got our H2O, and we still had our copper 2 plus, and our hydrogen and our H2O, but we now also have the copper metal. So the copper on the reduction side is not reduced. Copper can't be reduced, it's actually oxidized, so it's not going to be the copper here. We know that the sulfate ion will also not be oxidized. So on our reduction side, we've still got the 3 that we would have had normally. So we know from previously that it's going to be the copper 2 plus, so our reduction is going to be our copper 2 plus. Plus our 2 electrons to make the copper solid. And on the oxidation side, then we just need to look at the values again. So our copper is at the copper solid is our positive 0.34. Our water is positive 1.23. And our hydroxide is 0.4. So if we remember, if we're looking at oxidation, we're looking for the least positive value. So our least positive value is going to be our copper. So in terms of oxidation, what is going to occur is we have our copper solid becoming the copper 2 plus the 2 electrons. And if we have a balanced equation, these all cancel out. So there's no net product being actually made in terms of the whole system. It's movement of the copper solid and the copper ions within the system. This actually makes sense if you actually look at what's happening. So if we have our electrodes, and in this case, my cathode and my anode are both copper metal, and we have our solution of copper sulfate. So remembering that over here we have our copper 2 plus, and this is where our sulfate would have gone. So what's actually happening is at the anode, where there's oxidation occurring, this copper is becoming copper 2 plus. And that's going into the solution. They then migrate across to the cathode, and they become the copper metal. So this copper over at the anode slowly gets eaten away. So we get less and less of it because it's now becoming the copper 2 plus. Whereas at the cathode, it is now being deposited on the outside. So we get an increase of mass. So at the anode, decrease of mass. And at the cathode, there is an increase in mass. This is a way of actually purifying copper. So if I have an impure copper electrode at the anode and a very pure copper electrode at the cathode, or this could be also replaced with graphite, I can actually have the copper go across the impure, so the pure part of the copper coming out of the electrode being converted into the copper 2 plus ions, which then migrate and are reduced to become the copper solid over at the cathode.